going to review now the inyan that is called the menas govah medinah. What is the menas govah medinah? So first this is an introduction, and then we'll go back to the main thing. The introduction is like this. We have there in this picture the black lines are going to represent the horizon. This is the person's horizon. That means any stars that is underneath this black line he can't see. This is 10 degrees above his horizon, all these stars. 20. This is called the zenith, the top point. Now, the red lines represent the declination and right ascension. So this one here is the north celestial pole. It's seen 30 degrees. It's not, its roll should be 32. So this is the direction north. This direction is called south. And west and east are the two sides of the paper. So this is this north celestial pole. These stars here have a declination of 10, 20, 30, 40, 50, 60, 70, 90. I'm sorry, I went the wrong direction. This is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. So the way it works is that we start counting. This straight line here is the celestial equator. That's called 0. Declination of this is 0. Here's where the celestial equator hits the horizon. And here, all these stars that travel here have a declination of 10, 20, 30, 40, 50, 60, 70, 80, 90. That's the north celestial pole. So, the question is, stars that are going on the celestial equator, they are, after they reach this point, this is called the prime meridian. That's the highest point where they are. The sun, for example, is chatzos. When it's here, it's chatzos. Now they going lower and lower on the horizon till they reach here. That's when they set. So, question is, how many hours does it take from the prime meridian till it sets? The answer is 6 hours. Or you can say in terms of degrees, you can count them this way by counting. This one is 10, 20, 30, 40, 50, 60, 70, 80, 90. A star that has an declination of 10 takes him a little bit longer to set. He goes here, goes. I'm following this path. Okay, here he has already traveled 90 degrees, but sorry, it's here. Here he traveled 90 degrees at this point, but he's still not setting. He still has this tiny piece here to pass through. So that's why it takes him longer to set. You have to understand that the whole celestial sphere spins on this two poles, this pole and the south pole. So that will mean that for the stars that are on the 10 degrees declination, it'll take a tiny drop more, while a star that's 0 declination is setting. He is not about to set yet. He still has some amount to go till he sets. Now let's just follow this line. It's easier to this way. How about a star that's 20 degrees declination? Oh, he has another 40 minutes and more. I'm following this line because this line shows that the same right ascension, the star with the same right ascension, it depends on the declination also. Since he has 0 declination, he is setting. While with the ones with a higher declination, let's use this one here. This has a declination of 40 already. See, let's go here. This is the 0, 10, 20, 30, 40. So let's take a look at him. He has a long time to go till he sets. He has this, and this. So he has 40 degrees. 40 times 4 is 160 minutes. Now this is the system of declination. This is one of the basic stuff that I spoke about already once. I'm just reviewing it because maybe we're not so clear, so I'm reviewing it. Now, I'll show you a graph here that shows the function mathematically. Take a look at this one here. You can see here in this graph, you can see the beginning is cut off a little bit, but let's take a look here. Here you can see this part. This shows the x-axis shows the declination of the star. The y-axis shows how many degrees it must travel in order to be below the horizon. And as I said, if it has a declination of 0, it's exactly 90 degrees. And then it keeps on increasing. For example, let's take this number here. If you have it, let's go to an even number. Let's go to 10. Let's go 10. Oh, 10. Okay. What does this mean? 10. If you have all of this is in Eretz Yisrael. It has a 32. The latitude is 32. It depends on each country, because this is a trigonometric function. You're solving a spherical sphere that I'll probably show in the next video which kind of function you're solving here. But whatever it is, it depends on the place where you live, and according to that, we make the different graph. So this is for Eretz Yisrael. So let's say in Eretz Yisrael you have a star that has a declination of 10. You can see here 96.3. It means it's another 6 degree. It must travel 6 degrees. That is 24 minutes, maybe 25 minutes here, 26. So that's how much it takes, more than 6 hours. 6 hours is for declination of 0, and then as you continue the declination, let's go for 20 declinations. Go up here, 1992. Okay, 103. It means stars that have a declination of 20, it will take 103 degrees from when it starts off, from the middle of the day. So if you want to do it in an easy way, do 103 times 4. That's how much minutes? That's 412 minutes. And you can make minus 360, that's 6 hours. So you're left with 52 minutes. Extra 52 minutes. Now, just for curiosity, people are asking what is the longest day in Eretz Yisrael? Summer. So you can use this graph, because we know that the most the sun's declination can be in Eretz Yisrael is 23.5. So you push it up to 23.5. Let's push it up. 23.5. Oh, wow. Here you go. It's 105.7. So that is the maximum degrees. 105.7 times 4 is 422 minutes minus 360. 62. It's an hour and 2.8 minutes above 6 hours. So that Yisrael, it's very fair to say that the longest day is an hour, it's 7 hours. I mean, it's 14 hours because it's an hour each side. So from the Chatzos till the Shkia will be another 62 minutes. This is how you figure this out. So this is an interesting piece of graph. So this is the introduction for this video. The next video I'll show actually a trigonometric circle that this formula is based on. This graph is based on a formula. The formula is based on solving a spherical triangle, and this is a nice introduction to what Manos Govah Medina means. It basically means that since you have a Medina, a country that has a latitude, Govah Medina, that makes that the declination, that as you go up in a declination, the star should be long on the horizon. Because if you have no Govah Medina, for example, you live on the equator, it simply does not matter. All the stars are exactly 6 hours above the horizon. I mean, 12 hours, 6 hours from when it reaches the prime meridian. However, if you are in a govah Medina, means you have a certain latitude, as Eretz Yisrael is 32 or New York is 40, then we can say, hello, you got to find out what is the declination of the star, and accordingly to see, as I showed you in this graph, to figure out how long it takes for it to set. So first you have to have a govah Medina, if not, there's nothing to talk about. This is like, all of this, imagine that this point here would touch that's how it's by the equator, and everything would be exactly 90 degrees. Since this is govah Medina, this causes that certain declinations should be longer on the horizon, or certain things should never set. For example, these stars that have a 70 declination, they never set. Anyway, I hope you appreciated this shir. Thank you.